All right, ladies and gentlemen, we have a request to do a acid base with pKa's that I give you. Monoprotonated form of the tripeptide CER-ASP tier. Usually I tell you where what's what. And I don't know why I didn't on this one. Here's CER, here's ASP, and here's tier. I think most exams have something like that on it, right? I don't know why I didn't on this one. What do you think phenol means? I know sometimes we're looking ahead, but this one's based on something you have to know. And very importantly, it's new stuff you have to know, which you know will be on the test. PHEN. PHEN. Those four letters, what piece of the molecule are you looking for when you see PHEN? The circle? Circle. I'll go with the circle. There's only one circle. That's PHEN, right? Guess which alcohol I'm trying to tell you the pKa of. It says OL. It's an alcohol. There must be something real special about this one because that ain't a normal pKa for an alcohol, is it? It's not. Phenols are special. They're not like normal alcohols at all. And if you want a preview, when we hit chapter 10, we're going to talk about it again. Resonance. Yeah. Resonance of the O- with the benzene. But you didn't need to know that. You were just given that, right? Now go to the other end. Before we move on, what does tripeptide mean in biology? Some of you might know, some might not. He went right to the amino acids because those are the building blocks of proteins, and this is a very, very, very tiny protein with 3 amino acids only. Guys, you just said amino and acid. Amino is what functional group? It says it, an amine. Acid in amino acids is only one kind of acid. Which one? It's your only functional group you've learned that has acid in its name. Carboxylic acid. The thing I highlighted on the left, and I shouldn't have used pink. I should use a different color. Are these numbers closer to an ammonium pKa, which would be the conjugate acid of an amine? Or are they closer to a carboxylic acid pKa? If anybody thinks those are ammonium pKas, you didn't learn your pKas, please learn them. I don't want this being painful on Wednesday, okay? So guys, there are 2 carboxylic acids in this molecule. Actually, if you want to be picky, there are no carboxylic acids in the drawn version of this molecule. The pKas are given for that carboxylic acid and this carboxylic acid, and the numbers are 2.2. I didn't invent it. Where did I get it from? That's why I was sad I didn't label the amino acids for you, because that made this part a little harder, didn't it? I apologize to the previous students because that was on me. That was not my intention to leave the labels off of the molecule. You will have, and it's already made, you have labels on yours. So that's the 2.2 up there. What's this one? Please just give me the number. I'm waiting. 3.9. Okay, what's the only thing we don't have a number for? It's over here. What's the number for that? And how do I know that's the 9.2? I just want to say, guys, when you don't just ever think about the acid, think about its conjugate base at the same time. The only reason those don't have their H's is because of this prefix. What's this mean? Of all the hydrogens possible, how many are present? Guys, what's mono mean? 1. How many were possible? Don't say 2, don't say 3, don't say 5, don't say 6. How did I know there were 4 acids, 4 H's in the fully protonated form of this amino acid, or this protein? How do I know there are 4 protons when this thing is fully protonated? Reword that a little bit. How many pKa's did I give you? 4. When this thing's fully protonated, it will have 4 protons. Currently written, it has 1 because I told you so. How many are missing? 3. Which one goes missing first? The lowest pKa. Thank you. So on the key, you see this over and over again. It says missing. That's 1. After that's missing, you have the triprotonated version. What's next? Which one goes missing next? 3.9. Now, after the 2.2 is gone, it went to here. After the 3.9 is gone, this went to here. Which one's next? The 9.2 or the 10.1? Guys, which one reacts first? The stronger one. Which one's the stronger one? The lower number. Missing number 3. Okay, and that's that one. And how am I doing the arrows? This thing has become that thing. So that's the story of how we got here. This one came off first. Second. Third. Sorry, we had a question? We're good? Okay. So the third one's off. Now, guys, the versions that are drawn, it's a good exercise. It's a little bit of extra time that we don't have to spend. And on test day, I don't want you spending it. But I want a pKb for every base here. 1, 2, 3. pKb. You're going to use only one of them because only one is relevant. So of this guy here, what's its pKb? 11.8. What's the pKb of this guy right here? Yeah. Can I just write 10.1? Do I have to keep showing my math? You're okay, right? Oh, I should show the math for the one that's going to be the right answer. The next one. What's the pKb of that? 14 minus 9.2 equals 4.8. Correct? Of all the pKb's I calculated, which one reacts first? Smallest. This is the only pKb that's relevant right here. Gets highlighted in green. Why not? That's part of your answer, by the way. pKb 14 minus 9.2. I didn't copy the parts, but you know the parts. I hope. And you know, I totally forgot to talk about the most important thing first. I mean, there's nothing wrong with what I've said, okay? I skipped a step and I didn't tell you about it. How do you know the molecule on the left is an acid or a base? Because, yes, because of its partner, I have to agree with that. But to decide it, you have to look at the pair that's already there. and that's this pair here. I hope you agree, right? This pair is not already there. I don't know anything about that guy, right? So, of these two, which one is the acid? That's the question you ask every time. Left. How did he know it's the acid? It has the extra proton, right? It has one more proton than the other. What is the pKa of an ammonium ion? Because that's what this thing is. pKa is 10. I like it. That was weird. Your video is going to look terrible if that 10 is way over. Not your video, your pics. Where'd it go? It's going to be mostly empty space, this screen. Anyway, and look at this. Look at this. Okay. While we're here, pKb equals 14 minus 10 equals 4. That's part of your answer. Yeah, you identified an acid. What do acids react with? Base. Yeah, that's why I had to pick the strongest base over here. I totally forgot to talk about that. I apologize. I should have started here. That's why I was looking at pKb's. He said, why does he looking at pKb's? We should just look at the pKa's, right? Well, if this was an acid, it's more direct. You look at the pKa's from the beginning. Okay, lots of videos on those. Okay, we decided that's the best base because of the three numbers here that are they're all bases here. That's a base, that's a base, that's a base, that's a very weak base, that's a weaker base, that's a stronger base. Right here, 4.8. 4.8 is stronger than 10. 4.8 is stronger than 11.8. Lowest number wins. So you guys need a way of not drawing this whole molecule. Many of you are going to be surprised when you get your test back. Here's what you're going to write. You're going to say, because you saw it on my test, you think it's okay on your test. You're going to write R, NH3 plus, and you're going to write down pKa equals 9.2. For part A, you're going to get 1 out of 2. 1 out of 2. What the heck is R? No. If I'm not told, I'll just say, oh, R is tert-butyl, you're wrong. R is isopentyl, you're wrong. If you're not telling me what it is, I can tell you what it is. Okay? You need to circle everything up to and not including the NH2. Okay? I need something that shows well, red. And here's your molecule. I am carefully circling everything in the molecule, but I don't like the color anymore. Hot pink, there you go. Everything in the molecule except for the NH2, and you tell me I am calling that R. I want this to be the first semester that not a single student doesn't define R. I want everybody defining R so you can use it. But if you're just writing that down there, you're going to be losing a point. I got my point back because I got the pink circle on the left. Okay. That's part A. And we're almost done. The two acids we're doing here, there's a lot of stuff on this page now. The two acids are the acid on the left and the acid on the right. How do you determine pKeq from the acid on the left and the acid on the right? Every time. You are correct, sir. Left minus right. Don't reverse those. That'll be the wrong sign. It'll be the opposite reaction. Left minus right. 9.2. 0.8. And what's KEQ? It comes straight from that. No calculator, so you don't have to worry about giving me the 10 to the negative 0.8. And that's just the definition of K. pKeq. This is just a definition, everybody. Negative log of KEQ. You take 10 to the power of both. You guys never do this for me. I'm just doing it for you right now. 10 to the power of both sides. Legal math operation, right? 10 to pKeq is KEQ. 10 to the negative log pK. That's there. Right there. You don't have to ever show me that. That just gets you from here to here. Okay? And I didn't circle the arrow that's favored. How do I know it's this arrow here? pKa, yeah, these equilibria always go from the more reactive, away from the more reactive acid towards the less reactive acid. 10. 9.2, lower number, more reactive. We favor the higher number, less reactive. Point towards the higher pKa. Done every time. Yay.